I just realized that for the last problem, I never got the decimal because it says round to the nearest thousandth as needed. So let me go ahead and figure out what that 150 pi is in decimal. 150 pi is, and they wanted thousandth decimal place, right? So that's approximately 471.239 square millimeters per second. So when you type this into MATLAB, you're going to have to remember to give them the decimal instead of the exact number, okay? All right, so I'm back to do number 5. A spherical balloon, a circle, is inflating with the helium at a rate of 140 pi cubic feet per minute. I think I'm losing this slash there. How fast is the balloon's radius increasing at the instant the radius is 3 feet? Let me label some stuff here, okay? So what they gave us, this piece of information, the spherical balloon is inflating with the helium at a rate of, what I'm highlighting in orange is actually how fast the balloon is getting bigger, right? This is change in volume. So this orange is dV dt. And they're telling us that it's 144 pi. And it's increasing, so I'll keep a positive 144 pi. How fast is the balloon's radius increasing? So what are they asking for us to find? Okay, how fast is the radius changing? We are asked to find the r dt, change in radius with respect to time. And they're telling us that the radius is 3 feet at that instant. They want the dr dt of. So we have two givens. We know what to find, but where is that equation, right? So we need a volume formula for a sphere, okay? Volume equals, all right, let me try to see if I can memorize. I don't know if I memorize this. I think I'm going to go and Google this real quick. So I need a volume of a sphere. I think that's right, but just to be double, okay, so 4/3 times pi times r cubed. All right, so that's the volume formula for a sphere, a three-dimensional circle, okay? What are we going to do? We're going to go ahead and differentiate this with respect to time. So, guess what? The left-hand side will just be dv dt, and the right side will be equal to the derivative of 4/3 pi times r cubed with respect to t. So let's go ahead and work on the right hand side. That's dv dt. I'm going to multiply this 4/3 by 3, and that's going to give me 4, right? So 4 times 5 times r squared. The exponent goes down by 1, and don't forget to multiply this by dr dt. Okay, all right, I think we have everything to plug in. They said dv dt. Now look, this is interesting. What they gave us is the other side of the equal sign. 144 pi equals 4 pi times. Now what else did they give us? That the radius is 3. The radius is 3. So I'll put the 3 here. But what they want us to find is that change in radius with respect to time. So I'm going to go ahead and see if I can simplify this. The left-hand side is 144 pi. The right side will become 36 pi. And that's getting multiplied by dr dt. If I want dr dt by itself, I will divide both sides by 36 pi. So dr dt must be equal to 144 divided by 36, because pi's cancel out, and the answer is simply 4. So at that time, when the volume is increasing at 144 pi cubic feet per minute, on the radius, and that radius is equal to 3 feet, and the radius is increasing, it's getting bigger, at 4, what's the unit? Feet per minute. Okay, and that's how you can find the answer for this problem.